Olá, gente. E aqui eu tô no episódio número 22. Hoje eu tô com o Albert Corazzato e vai ser uma experiência diferente. A gente vai falar em inglês hoje, então vamos ver aqui quem consegue entender inglês. E eu vou fazer agora uma introdução em inglês do Albert e a gente vai começar a falar sobre a experiência dele trabalhando na NASA em Houston, nos Estados Unidos, ok? Então vamos lá. Hey, folks, it's episode number 22. I have Albert Corazzato with me today. Albert has a degree in computer science from the University of Houston and has been working at NASA for 25 years now. Albert works on the International Space Station Simulator and more recently on the Orion project, which is Lockheed Martin's next generation vehicle to take humans back to the moon. Albert is also working on the SpaceX project, helping with the integration of SpaceX and NASA's training simulators at the Johnson Space Center. Albert, thank you so much for joining today. I look forward to hearing about your story and experience, and it's very exciting to be talking with you.
Thank you for the invite. This is very exciting for me as well.
So, Albert, first question I'm going to ask you is we spoke about some time ago. We're both geeks, right? And we know that we love some science fiction shows. I was just wondering if you could tell me what kind of influence science fiction shows such as Star Trek and Space 1999 had on your life and your career at NASA.
Well, as a child, as a kid, I was always interested in space and shows like Star Trek. By the way, Spock was my favorite character. With the future technology they had and the science they discussed, just piqued my interest. You talked about Space 1999. Space 1999 was based on the moon in the science fiction series, and liking NASA, I always watched shows about the Apollo program and men landing on the moon. So everything that I saw on those shows, whether it was the physics or whether it was the spaceships or whether it was just the technology, just had me interested as any child, any geek like us would be. Um, I was always curious as to if the technology or the ships were real, if they were fantasy, or if they were something that could happen in the near future. So that's what kept my mind going when I watched these shows, and why I watched them over and over again. Anything from a tricorder to a phaser to the Eagles of Space 1999. I always wondered if that was a possibility in the near future, and could I be a part of it? Because I just found it very interesting.
It's also interesting how if you look back at those shows, especially Star Trek, when they are using like something that looked like a tablet or something like looked like a cell phone back then, those technologies are here today, right? So we have cell phones everywhere, we have tablets everywhere, and I keep looking forward to the teletransport and also to the holodeck, which will be a lot of fun. Just wondering, how did that trigger your interest in all things electronic? Because you mentioned to me that you used to take things apart and put things back together. Did that help with the interest in electronic, and what did it mean to you to have the exposure to the electronics?
Well, yes, the shows like Star Trek always that helped with my interest. So if you ever watch some of the Star Trek shows, you'll see Scotty, saving the day by fixing things and coming up with new ideas, and thinking, using his brain, and helping get everything solved. But when I was a kid, I used that helped. Certainly, as a kid, as a young child, I had an interest in how things worked, and definitely the shows like Star Trek and Space 1999 and other science fiction shows um, enhanced that desire to understand how things worked. Because you'd look on the television shows and you would see these people doing it, and I would think, hey, that's okay. That's interesting. They can do it, so can I. It's not bad to look at your record player and figure out, hey, it's not working anymore. Can I take this apart like Scotty and fix it just in the nick of time so I can play a record this evening? They definitely help. Now, when I was a kid, as you and I spoke earlier, when things didn't work, I always thought, hey, it's already broken. I can't mess it up anymore. Let's see if I can fix it. Sometimes I was successful, sometimes I wasn't, but that's how you learn. That's how you get experience, by figuring out what works and what doesn't. So they were very helpful.
Yeah, we always tell the kids who take part in our programming group that it's important to try, right? It's important to practice. That's how you learn. That's how you evolve in your career, and that's very important for sure. And can you tell us a little bit about your high school? Like, I think you mentioned to me that you had a computer math course on, I think, on grade 11. That was that triggered your passion for programming computer. I was hoping you could tell us a little bit about your overall high school experience and how that specific computer math course kind of got you hooked into programming.
Sure. Well, I'm old. Computers were just coming out. Personal computers were just coming out when I was in high school back in the 80s. When I first started high school, I was interested in engineering, physics, math. I liked math a lot. I really did. And I started thinking about what I wanted to do when I graduated. This is back at ninth grade and 10th grade. And I thought of anything from math to nuclear physics, because I found that interesting. And the nuclear physics does kind of go back towards Star Trek, with the dilithium crystals and the warp drive. So there's a link there. But in 11th grade, they had an elective course called computer math. And I'm glad they called it computer math because I liked math. And we had the old Apple II computers, if anybody wants to go look in a museum and see what one of those looked like, where we programmed in BASIC, and our instructor gave us math problems to go solve. And I enjoyed that. I found it very interesting. And after the math problem was over, because this was a new course and the instructors didn't have a basis for how to teach this course, this is brand new, we had a lot of leftover time. So there were other geeks like me in the class. So after we finished our math problems, we started exploring with what we could do on the Apple and on the personal computer. We would start writing programs where we could peek and poke into memory, and we would play hide and seek games on the floppy disks, if anybody remembers those, where we would put messages on different sectors of a floppy disk and hide them. So every so often we would trade floppy disks, and our task was to obscure the low level parts of the language to go in and try to find these little areas on the floppy disk and find the secret messages that we put out there. And just like I said, it was a hide and go seek game. So that was just fun for me. Just the idea of being able to go root around inside the memory, inside the guts of the machine, and that kind of turned me toward computers right then. And in 12th grade, I took another computer math course, and by then I was hooked. I still like math, I still like physics, but the computer science part just took me over. So that's how everything started way back when.
It's just amazing how the microcomputer revolution in the 80s that was so important, and how many people had the beginnings of their careers by getting exposure to the Apple IIc and to the Timex Sinclair 1000, the Zilog kind of computers back then, and it's just really impressive there. And also the what you mentioned about experimentation, it's so important to try and to see what happens if you play with BASIC. Playing with the programming language at the time that came with those computers, and it helped you understand programming, and helped a lot of people write their first programs, and even make some money back then with consulting services to companies that wanted to do some sort of automation, right? So it's really absolutely fantastic. And then you finish high school, and you I think you mentioned to me that you took a degree of a junior college. I think it was a junior college associated degree of science, and you're majoring in computer programming and architecture. Can you tell us a little bit about that overall experience and what that degree did for you?
Well, sure. Well, again, when I graduated high school, computer science was a new degree plan, a new career. Computers were just nascent, so everything was nice and young. A junior college near me had a an associate's degree in science with specialty in computer science, where they taught you everything about computers, from hardware to the electronics to different software. And in that course, I got to play with math. I was taught electronics down to the chip level. You had mentioned earlier about the breakout of all the electronics with the IC chips and everything. I got to experiment with those using wires and learning about how the TTL logic of the computers worked. And you used CPUs and flip flops and just all sorts of chips to make your own little working computer. They also taught me how to program in many different languages. And they extended my knowledge from the Apple II and BASIC to the IBM PC with the old 8086 CPU, how to program and how to manipulate different things inside memory to a greater extent using all sorts of languages like Fortran, assembly, Pascal, C, C++. And that that was just an eye-opening experience. I mean, this was what I really enjoyed. Not only could I take a computer apart or build one using breadboards and circuits and wires in my electronics courses, but I learned how all the chips worked. Like I said earlier about flip flops and how the CPUs work and how different clock cycles affected them, uh, and how to integrate that on a low level with the new languages that were coming out. So that that 2 year degree helped me understand everything and cement my desire to get my degree in computer science. And it pushed me, I could say, toward my confirmation that I really did want to work at NASA and with computers that were on the cutting edge or developing new technologies, new things that other people weren't doing. So it was very formative for me.
Albert, our listeners, they probably don't know what a breadboard is or flip flops. Would you mind giving us a quick overview what breadboards do for you and what flip flops are?
Of course, I'm sorry. Well, back in the old times, back when I was young, chips were not as small as they are now. Imagine a hardware board. We call it a breadboard. Imagine a board that has a lot of little individual sockets in it, where you could plug chips like memory chips that were a lot bigger than we have now, memory chips into these little sockets. And these memory chips had pins on them that had power, where you add power and you ground them just like an electrical circuit. You put power on one pin and you would ground it on the other, and you would have signals, or your clock cycles would go into something, or another pin, or a trigger would go into another pin, and you made the chip operate as it does now in a computer. But you don't get to play with them now as you did back then, because everything is nice and small and integrated all into one little chip or one little tiny board. So these breadboards were about as big as your keyboard, times two. And we would take chips that were called flip flops, which we use those to trigger different other chips inside on the breadboard that simulated what goes on inside a computer. So we would have an old Z80 CPU, which was just a 4-bit CPU. We would have an external clock source. We would have these other chips that acted as memory, and we would use that external clock source to trigger these external these flip flops or these memory chips to cycle data through them, and it's just like a big. I don't know how to explain it. Maybe like a how you would take a Legos set now, and you have all these individual little blocks, and you would build something, and be it a Death Star or whatever. But back then, this little breadboard was just a bunch of sockets that you could plug wires into, or a CPU into. If anyone out there has any experience with Heath kits, which were old radio kits where you could build, you could go pick this up at an electronics store and build your own radio or anything like that. It's similar to that. So it's pretty much a build your own computer, very basic computer, but build your own computer on a little circuit board that you had access to. And it helped you understand how to wire or how the computer was wired to make it work between the CPU and the other supporting pieces of hardware. I hope that explained it well enough.
It did. Thank you so much. And it's similar to what in a way it's similar to what you can do with Arduinos right now, right? No, I'm sure you have been Arduinos. You can. It's you can play with a breadboard and Arduino. You have a little C programming kind of IDE that allows you to trigger a few reactions and do a lot of interesting things with those boards as well. And it's a great way of experimenting and learning, right? So which is absolutely fantastic. Then you finish your degree. You decided that it was time to go to the University of Houston for a computer science course. Can you tell us a little bit about that course and what did you learn over there as well?
Well, sure. The University of Houston, the branch down here in Clear Lake, Texas, is just a half a mile from Johnson Space Center, NASA. And because computers were so new and programming was becoming so ubiquitous across NASA, they decided to team up with the University of Houston and develop a computer science course that was beneficial to the NASA community. In other words, you could get your degree in computer science that centered on the technology or the courses that NASA really wanted in an employee. And if you did that, you were set. You're pretty much set up to get a job at NASA if you wished. And that's what I did. I found that very interesting, and it kind of played into my my new career path of working with computers and working at NASA. So I got my 4-year degree. I got my bachelor's of science in computer science at U of H, and in that course they taught us all sorts of stuff that was brand new, like how to mostly mainframe stuff or large computer stuff using the Linux system. And we programmed extensively in C++, and we also learned a new language, Ada. Well, it was new back then. The Department of Defense and the government used it a lot, which is what the space station software is programmed in. They nurtured us and developed our skill set to transition straight into NASA. It was a wonderful experience. We got to work with people who were former or current employees at NASA. They would come over and teach us and tell us how things worked currently with the in the space program. And once I graduated from there, it was just a matter of time before I transitioned over to NASA. The degree was it was very interesting. You got to play with all sorts of neat hardware and software. And you had mentioned earlier about the Arduinos. Imagine doing stuff like that, but on much larger systems. You get to experiment and see what works and doesn't work, and how this is going to tie into new technologies. It was it was very interesting.
So, Albert, you mentioned that the International Space Station simulator was developed using Ada. Just wonder if you could speak a little bit about the language and what kind of benefits it brings to a complex, well, super complex application like the International Space Station simulator.
Okay, yes. Well, the Department of Defense the government originally started using Ada back in the 80s, early 80s. And the benefits about Ada is that it is very fault tolerant. So, what I like to say about the C programming language is that it gives you a lot of rope, and it also gives you enough rope to hang yourself if you're not careful. Ada, on the other hand, was a very fault tolerant system. It had a lot of checks. It was very wordy. You can go Google this and check it out. But it was a very wordy language. Did not get it was not object oriented for a while until the 90s. But the because this was a government project, the space station, it was decided that they program it in Ada again because of the fault tolerance. When you have men's lives or people's lives, humans' lives in danger, like they do on the space station, or equipment that could fail catastrophically, you want to make sure that you have a lot of fault tolerance. You don't want things to go wrong unchecked, and if something does go wrong, you want the system to be able to recover and have a safe response instead of crashing, which could be catastrophic. So that's what the space station, the current space station that's up, the ISS that's up there now, all the software that runs on the computers up there, the over 40 computers that we have up there, are written in Ada. So that was the beauty about that language. I really did like it. Unfortunately, it didn't become that popular in the mainstream geek world. That's why it was selected. And for the simulator, the fault tolerance was really good. Like I said, if anybody has any experience out there programming in C, and your system crashing for no reason and you don't understand why, Ada pretty much told you this is why it crashed and this is how we're handling it. We're going to bring the system down nicely. We're not going to crash off into some deserted piece of memory where you never know what's going on. It was a unique experience.
I can imagine the complexity and also like you mentioned, life's at risk, right? So the importance of having the proper technology there is essential. Right? Now, I just wonder, you mentioned Linux and C++ as well. I was hoping you could speak a little bit about the importance of Linux and the importance of C++ on the simulator as well.
Yes, currently the simulators we're using now, or excuse me, the Orion, like the Orion simulator that Lockheed's developing in SpaceX, they are developed in C++. I'll talk about Orion because I work on that a lot. Everything is in C++. As far as if I'm sure many people are familiar with C++ and its benefits. It's very fast. It's very good, but you have to be careful. All our systems are Linux based. We use the larger computers. None of our stuff is done on Microsoft or any, on Microsoft PCs or anything like that. Everything that we do is on the larger computers, which Linux based. You get to use the GCC compiler, the G++ compiler. So it's quick. The good thing about C++ and the Linux system is that it's quick. You have a lot of tools. And what I like about the system is that you have, if you understand the system and the language, you have unfettered access to go look at all the neat memory, and what's going on inside the guts of the system. What I like about the system, and this is just me from my standpoint, my geek standpoint, is I like to see what's going on deep inside the memory of all the computers, all the models, all the subsystems, to see what is going wrong and where. Instead of using tools, we write them. And it's very easy to do that in Linux and using C++. Sometimes you don't get the results you want, but when there is a problem, that platform allows us to debug stuff on a level that is down to the bits, hexadecimal or just binary, and it's very interesting for someone like me, and it really does help with the problem solving. Something that I've never been able to get using anything Microsoft Windows based. I like to get down into the guts, or at least not when I started programming anyway. So that's why I like Linux, and that's why I think the Linux and the C++ is very interesting right now.
Just going back in time again, and just you finished the work at the University of Houston there, and you mentioned to me there was a job fair, and you went through an interview process. I'm assuming. Just wondering if you could speak to us about tell us about the job fair, and how was the interview process, and how was it when you started to work with building the International Space Station simulator.
Sure. Well, when I graduated college, the the market here in Houston for all technology was kind of on a low, on a downturn. So I spent the next 6 months working at another job and actually reading more and playing more on computers. And then, beginning of the year, there was a job fair at my old college at the University of Houston, and I printed out a bunch of resumes and went there and started handing them out. And what's interesting about this one is that I went around. They had a bunch of tables in a big open area, big atrium area, and I was handing out my resumes to these different companies. And as I was leaving, I had one resume left, and I just happened to go by this one little table that was off in the corner. And I handed this resume off to a person that was at the table, and he stopped and he looked at it and he started reading it, and he got real interested, and he said, Albert, do you know anything about virtual memory? I said yes. And he says, he asked me a few other questions, and I answered them, and he just kind of said, huh, okay. And he put it on the stack, and he says, we'll look at it. I said, all right, I've been here for a couple hours. I'm going to go get something to eat. 2 weeks later, I get a phone call from that company, no one else but that company, and they said, hey, we're interested in you. Can you come out and talk with us? So I had an interview at this company, and I talked to three different managers in three different departments, and they were all very interesting. But the one I really liked was the one I work with now, and I was originally supposed to have a 20-minute interview with the manager for this department. It ended up being about an hour because I just kept asking questions, and he just kept drawing on the whiteboard, and I was so interested in this department, I just couldn't, and what they were doing, I just couldn't stop the interview. And he didn't stop the interview either, so I found that a good sign. And I went home thinking, hey, this was really fun, because this was my first major interview, and I was very nervous going in there, thinking that this was going to be really hard and that I wasn't going to be very successful. But 2 weeks later, they gave me a call and offered me a job working on the space station simulator for NASA. We were subcontractors for NASA, and when I started working there, I still remember the first day working there. I remember everything I was wearing. It was an eye-opening experience working with these people who were developing stuff from scratch, from the ground up, to facilitate training and for training for the astronauts, and training for the flight controllers, and flight software verification for the real flight software that's up on orbit now, and developing the new technologies to do that. So that one last resume at dropping that off at that one little table off in a corner changed my life, and it was just so strange, so weird how all that just came together, and that made my career right now.
It's just amazing how things happen in life, right? So the last resume on the bio, it's you walk by somebody, you give them the resume, and that triggers a whole chain reaction in your life if you want to look that way. It's also important to mention something that you said here because we have our audience has a whole bunch of very young people who are they're questioning, okay, should I go into technology, should I not go into technology? They're nervous. There's a pile of things, a pile of technologies that they have to learn, everything from computing languages to IDEs and computer architectures and all sorts of technologies. But you go back in time, you're in the boat that these guys are now. So you told me you're nervous about the interview, right? So, and here you are, 25 years later, you work at NASA and very complex applications helping the future of space exploration. I think it's a very good example to show the kids that we're talking to here that everybody is human, everybody feels nervous, and everybody feels it's normal to feel uncertain, afraid about the future and whatsoever, right? So when you go to an interview, and it's very important to understand that everybody goes through that process. And can you tell us what exactly is a simulator, and what's the importance of that simulator, like the International Space Station simulator, to the success of the mission, to the success of the program? Can you tell us a little bit about that?
Well, sure. For the International Space Station simulator, what you do is you simulate, as the name implies, what the software and all of its related parts, the entire system will do up in orbit. So, in a nutshell, if you want to experiment with a computer program, in this case, a system that's running on one of the main computers in the space station, and you want to see how it reacts when it uh, talks to or communicates with a certain sensor or a pump or a switch on the space station. We all know that when you design software, you have to go test it. The simulator allows us to test it in a safe environment where we don't destroy real equipment, where everything can just, if things go wrong, you can stop and debug it. You can hit a reset button. You can try it over and over and over again to find out what's going wrong without impacting anyone or anything but time. Many of the pieces of equipment up in the space station are very expensive, $5,000 switches, $10,000 switches. You don't want to break any of those by testing it out. So that's why you test it on a simulator. You try to debug everything and make it perfect before you send it up there to operate a very large, very expensive vehicle, and especially when human lives are in the balance. When Boeing writes the flight software for this, they test it, we test it on our simulator. We also use the simulator to develop procedures because this is new. The space station was never, we don't have any precedent for that. I mean, we had Skylab and there was Mir, but this is a brand new piece of equipment and a brand new technology. And NASA had to figure out how to write procedures to help these astronauts do what they want to do. Does this procedure work, or should we tweak it to do something else? If we do procedure X, how does that affect the software when it talks to these other computers or these other pieces of equipment? We use it for flight software verification, and we also use it for emergency contingency. So if you're up there on the space station and a computer fails, and it unexpectedly, and it has a negative effect on the entire system, you don't want to be the flight controller on the ground dealing with that problem when time is of the essence and people's lives are at stake, or at least either the people or the machine or the entire mission could be a failure. So the simulator allows us in a real-time environment to run all the procedures, all the training, and all the verification here on the ground in a safe way, in a safe environment. So when we do implement them on the real vehicle, the risk of anything going catastrophically wrong is minimized.
It's um, it's an incredible complex piece of software, right? So I'm just wondering, how long did it take for the simulator for the International Space Station to be developed and be brought to production? Do you know?
Yeah, the simulator is pretty complex. The space station simulator is pretty complex. At one time, I believe I was told it was the largest real-time simulator in the world. That's just because it had to be. I mean, space station is not a simple vehicle at all. So the simulator had to develop along with the space station. Space Station Simulator started in the early '90s, so it took about 20 years. I mean, we're still tweaking it now, depending on what our task is. But it took about as the flights went along, the space station flights started off small, and the simulator started off small. The simulator was about 6 months to a year in advance of the space station. So if you wanted to do something on a space station or you had a flight going up at a certain date, 6, 12, maybe even 18 months prior to that, the simulator had to be ready to train and or test what you were going to put up in the future. It pretty much ran along lockstep with the space station project. About 20 years, I would say. There are still some things we're tweaking now. Earlier, we had talked about the Orion project, the Orion simulator, integrating with the space station and the space station simulator, as well as SpaceX. There are new things that are developed to support them. So it's actually growing, and it's actually we're constantly modifying the simulator to take those into account. But to answer your question, it took about 20 years before we were at a nice place where the space station was complete, and the rest is just tweaking and adding new features.
New features continue to be added, which is exciting to see as well. I was just wondering if you could explain to our audience what's the Orion project? What does it bring into the equation?
Well, I'm sure somebody out there, you guys have heard of humans, America wanting to go back to the moon. Humans wants to go. We want to send people back to the moon, and this time to stay. Boots on the moon, and back in the '60s and early '70s, we went to the moon, we explored, we came back. We haven't done anything since then. But now the governments and humans want to go back and stay. So there's a project you can go look about. It's called the Gateway Project, where we plan on having a space station, or a little space station orbiting near the moon. The Orion project is Lockheed's development of a capsule that will take us back to the moon, back to the to the Gateway Station, and back to the moon to stay. So, if anybody is familiar with the Apollo project and the Apollo capsule, it looks kind of like an Apollo capsule on steroids. It's a lot larger, but and instead of carrying 3 people, it can carry 7. And it's not just a capsule, but an entire project on getting people back to the moon to stay. So that's what we're doing right now. And because of NASA and because of their involvement with NASA, we have to help with we help with that simulator, and to make sure that everything is works well with the Mission Control Center down here in Johnson Space Center, and the astronauts and the flight control.
So is it an expansion to the existing simulator, or is it a completely new simulator that's being developed for that specific project?
It is a completely new simulator being developed for that project. It is not an expansion, but they use the same interfaces that the International Space Station did. So when you have to talk to Mission Control and train the astronauts, we have a complex training system at the Johnson Space Center, and the communication to mission control, to make sure that the flight controllers know what's going on. It's not exactly an expansion to the space station simulator, but they're using some of the same technology that we used with the space station simulator.
And when you mention simulator, I always think about going back to that Apollo 13 movie, right? So when they had the problem, and then one of the astronauts that was on Earth, they got handed to some sort of a real time simulator at the time there, which is certainly nothing to the level of complexity and sophistication that we have today, but they're running different configurations because they're trying to save power and to bring the Apollo 13 back to Earth, and they had to run within a specific power, and they're running simulations at the time to do that. Can I'm assuming the existing simulator for the International Space Station has all sorts of functionality that can help with any troubleshooting that needs to take place at the space station, correct?
Yes, definitely. In fact, the company in real life, the company who developed the Apollo simulator is was the company that I started working for way back when, 25 years ago. And yeah, they've got a long history of doing simulators for NASA. The current space station simulator can do all that to a much finer degree. There have been several times, and you can go check, past news articles and stuff. There have been several times where they have had incidents on the space station, power, issues, or something that just doesn't look right, that we have run tests over and over again in our simulator down here on Earth. And then the instructors or the flight controllers would recommend changes or new procedures to the astronauts up on the space station to fix that problem. So it has been used just like in Apollo 13, where you have Gary Sinise sitting in the simulator here on Earth trying to figure out the power sequence and how to power things up to get everybody back into Earth's atmosphere without running out of power. We've done several real simulations here on Earth to help with issues that have popped up. So yeah, it's just like that, but to a larger degree. You have many more computers. You have a lot more pieces of many more pieces of equipment connected to it, and it's really cool. It's exactly like that. It helps you debug current issues and anything that may come down in the future. So try to mitigate all these problems. Yes, it's a lot of fun.
That's fantastic. And can you tell us a little bit about everybody is these days we're seeing the SpaceX rockets bringing Americans back to the space station. And you mentioned to me that you work on some of the integration, some of the SpaceX and NASA's training simulators. Can you tell us a little bit about that work that you're doing?
Well, on the SpaceX side of things, I'm mostly just assisting with debugging problems. So as with any new project, you're going to have issues or growing pains. And because SpaceX sends capsules up to the space station, they have to work with the current space station that's up there. They have to be able to communicate with, dock with, mate to, and just work with the current equipment up there. So the simulator, SpaceX, their simulator has to communicate with our simulator to make sure that the training that they do will be effective, and we can find any problems that may occur. So if there are any issues, or when there are any issues for SpaceX, I'm assisting with debugging those problems. So if for some reason when we integrate two sims and you might have an error show up that is unexpected, we have to figure out what's going on. And a bunch of people, including myself, will go take a look at the data, come up with some ideas, use our current tools or develop new tools to peek through memory and look at the data that's going back and forth to figure out why that happened. That's the extent of my work on the SpaceX integration of the simulators right now. So it's just debugging and making sure everything works well.
What goes through your mind when you look back, and we started the conversation here talk about Star Trek shows and Space 1989 shows. What goes through your mind when you look back in life and you think about you watching the shows, and then you all of a sudden you realize you work at NASA and you're in the middle of the space program and you're working on some serious business that's helping us bring humans to the moon. Eventually, we're going to get to Mars and beyond. What crosses your mind when you think about that past and you realize you're in the middle of the thing right now?
Okay, this may sound a little silly, but if you look back at Star Trek, um, they always, in the shows there were always problems where Kirk, Spock, or Scotty had to solve some kind of problem. The ship was going to blow up, or there were some aliens that were keeping them from, that were about to kill them or something, and somebody had to come up with a new and novel idea and problem solve, their way out of it. Scotty would always save the day at the last minute by, adding something or crossing something over, or something like that. When I look at what I'm doing now on the space station simulator, whether it's just the ISS or whether it's with Orion or whether it's with SpaceX, I sometimes think about the technology that they had back then and the thought process that the actors in the show or the characters in the show went through to solve their problems and get them out of the issues that they're in. Now I look at myself going, hey, these technologies are brand new. Some of them aren't, but some are. I mean, capsules going to the moon to stay is definitely new technology. And I still I still think about the problem solving techniques that I was introduced to in shows like Space 1999 or Star Trek. Back back to the Scotty thing, or back to Spock coming up with an idea. And earlier we had talked about when I was younger and how I like to take things apart. And I I was very interested on problem solving or troubleshooting back then. My record player didn't work. Why? Let's see if we can figure it out. Scotty and all the characters on Star Trek and Space 1999 and other shows like that had to come up with new ways to solve problems quickly to save their lives or to save their ship. But now, when I'm working on the simulator, we come up with new and novel problems that either have never been seen before or have never been solved before. And I find myself using that same kind of thought process, or the same technique, the same attitude, use it the same way that those characters use to solve a problem and to save themselves at the end of the show. We're doing the same thing here, and it's like a what if. Hey, we have this problem. Everybody's looking at the data on this end. What if we go and look at it from another end, kind of like Scotty or Spock would do? Perhaps what we're seeing is not where we should be looking. Let's go look on this end. Ask questions. Uh, make educated guesses. Go experiment. Is this going to work? Are we going to of course, what we're doing down here on the simulator isn't as life and death as it is on Star Trek, but that's how I think that influenced me, or that's what I think the old shows like Star Trek helped me, and how it helped me do my job now, and still does. I find that the biggest influence on my job now, how to problem solve. So if my biggest asset from these shows, or how these shows helped me so much, was how to ask questions, how to just be inquisitive, how to poke around and try to solve the problem from a different angle. And that's how I think these shows have influenced what I do now.
And when we're talking about the influence that those shows had on you, and it's all the problem solving, all the way of getting anything resolved, because you're dealing with new stuff all the time. You're dealing with surprises. And you have to be creative. You have to be troubleshooting. You have to be asking questions. And that also takes me back to the education that you accumulated, right? So I'm just wondering how looking back at your first programming courses and your degree at the University of Houston. Just how important was it to the job that you have today?
Oh, it was very important. With the programming courses that I took at the university, many of the courses were integrated with hardware. And not only did we learn how to program in a computer language, but we learned how to use those languages to influence hardware on the most basic level. It's like a hardware software integration type aspect. The courses, like I said, at the University of Houston were specially tailored by the Johnson Space Center, by NASA, to give us the education and the experience needed to work there. Courses that I took gave me a new insight into how software works the way it works, and how these compilers compile programs, and how you go from a computer language like assembly or C++ or Ada, and how you to computer language through the compiler, how a compiler takes that, takes the English, the stuff that we see in English, the stuff that we see on the screen, human readable, into machine readable, and how it affects the hardware. And the hardware software integration part of those courses really did help and open my eyes into how things work on a larger system like the Space Station Simulator. And going back to Linux, you were mentioning Linux earlier. I really liked, the one thing I do like about Linux is that it's command line. Everything's nice. You type in everything and you have a very high degree of control about what you do and how you can influence the system. So the courses really did open that up for me, show me how we could do that down to that machine level.
Albert, talking a little bit more about Linux and the tools, can you tell us a little bit, if possible, about some of the tools you're using VI, you're using other open source tools to help in your day-to-day activities, or anything special that's public knowledge?
Sure. Well, we do. There are many different editors that are basic editor, like you mentioned, Vim or VI, gedit or anything like that. We use those to edit or play around or to work on our systems. We also use other tools like some IDEs, some integrated development environments that help us with the computer languages. So, Microsoft has a suite of tools that allow you to write C++ and to compile it and to edit it and to debug it on their system. We use tools like Eclipse, which is another programming IDE, to analyze and to edit our C++ programs. It also has an Ada extension, so we can do the same thing to Ada. If we need to go debug that, we can use that to put breakpoints in. We use the standard Linux debuggers, GDB, to put breakpoints into our software to see what the values are when it breaks, just before it breaks. We also write our own tools using C++ to look into memory structures. So, on our end, we have many virtual machines that we have on our system. And inside those, for each virtual machine has a certain computer. We know the structure of the memory. We know how that computer is laid out. So we can write our own tools to go into blocks of memory inside this virtual machine and strip out whatever bytes or words or blocks of data that we need, take that data and analyze it later on down the line to see what's going on inside the guts of the machine. So anything that is open source on Linux is usually allowed on our systems. Like you mentioned, VI. We use VI all the time. Depending on who you are, you might want to use something a little bit more graphic, like Nedit or gedit or something along those lines. We don't use anything too intensive. GDB, we use all the the C++ compilers on Linux have some nice debugging features that we use to an extent. We do, like I said, we do use some tools that allow us to we use the integrated development environments like Eclipse, etc. But everything on Linux that is out there, that's out there that's in the development environment of Linux, that's in the release, whatever release you're using, we usually end up using. So it's it's pretty standard what anybody in college or anybody in school would use.
Are you guys using Git for versioning control as well, or are you using other software that you guys have created?
We do use Git. We started using Git several years ago when we switched over to a new computer system, and it works well. We do use Git all the time. So if you guys have any configuration management background with Git, I suggest that you keep learning that. It's quite ubiquitous. And we do use that a lot on our system to make sure that we keep everything up to date and we don't get any of our code crossed with older versions.
So if you look at the programming website that we created for the programming group, we have some computer or computing challenges over there, and development challenges, I should say. And the first challenge that we have is it teaches people the basics of Git, and there is a challenge where they have to commit a change and do a pull request to a repository on GitHub. So I guess we can tell people there that if you learn Git, you're using some of the tools that Naz is using, which is absolutely fantastic. So just again, looking back at an incredible experience that you have and what you have been doing, what would you recommend to those who, dream about following a career path similar to the one that you follow, the same way that you watch the Star Trek and Space 1999. The kids today, they're looking at this SpaceX and NASA rockets and all the rockets going up, and they're seeing people talking about artificial intelligence, all sorts of technology, and all this mobile revolution that we have today. What would you recommend to those that have the same dreams that you had back then, and they want to follow a career path that's similar to the career path that you took?
Oh, wow. See, that's interesting. Kids today have access to so much more information than I did when I was back in high school and college. Back then, the only access I had to what was going on was, television shows, magazines, and just word of mouth. Several friends I went to high school with, their parents would work for NASA or for IBM, and I would talk to their parents about what's going on, and that would pique my interest. And of course, all the technologies were kind of new back then. Now, if any word of advice for kids now is you have so much access to so much information about what's going on. You get to see everything happening in real time with SpaceX and anything that has to do with the new lunar missions, about the Gateway mission, about Orion, and what's going on with our next steps to the moon, putting boots back on the moon again. I would suggest keep a healthy interest. Ask a lot of questions, and if you see anything that interests you, whether it's robotics, whether it's aerospace engineering, whether it's any of the biomedical sciences, because we're going to be learning a lot more about that. Do as much research as you can. I mean, find what you like. There are so many avenues to go down. Keep that healthy inquisitiveness out there. When I was younger, I wanted to know how things worked, and I found that with my limited access to what was going on in space, I dreamed, I thought, I just asked questions, I thought of things in my head. Nowadays, kids, I would keep that inquisitiveness. I would look online and just at the flood of information you have about what's going on with space flight and who's doing what, whether it's SpaceX going back up to the station, landing rockets vertically, whether it's space tourism, or whether it's going back to the moon and doing deep space exploration. Find something that just makes you want to go research it even more, and keep doing that. And um, your opportunities are, you have so many opportunities now. Your opportunities are greater than anything I could have thought about 20, 25 years ago. Don't stop asking questions. Don't don't stop thinking about what what's out there. Don't get discouraged. But if you just if I would have to say one thing, do your research and just keep asking questions and keep trying to find the answers out there, and eventually you will find something that you do like. And I find that that's exactly what happened to me. I just kept asking questions, and all of that came to a point when I had that interview, and I still remember that interview, and all my questions, all my inquisitiveness just came out, and that's why I'm where I am right now. So you guys are living in a wonderful time. It's a wonderful time to be alive right now. Just look look out there for anything that interests you and ask questions, and you'll find what you love. And if you're interested in anything space related, you will find that it will just it will present itself. I am so envious of everybody nowadays, and how much the access to the data that you have, and all the new things that are happening at such speed. That's pretty much what I would. That's my advice for everybody now, all the young ones.
Thank you, Albert. That's a very good recommendation there to the people who are trying to figure out what the path is in life, right? So there's plenty of people in that situation right now, especially there in Brazil, and it's very important all the recommendations that you provided to them here right now. And Albert, looking at the future, and how do you see the future of space exploration and technology in general?
For the future of space exploration, I do see us. I mean, a lot of people are wanting to go back to Mars, or go to Mars, excuse me. They want to go to Mars. They want to go to Mars in the next 20 years. The way I see it is that we will be taking steps to go back to the moon, and like the space station and the earlier space stations like Mir, the Russian Mir, and the American or the International Space Station with international partners, Russia, Japan, Europe. I find that going to the moon will be similar to what we did with the space stations. We're going to learn a lot more about space when we are away from our protective Earth. Space is not. It's a very harsh environment. So my future for space exploration is to go back to the moon, to stay there, and to use that as a stepping stone to Mars and other asteroids and deep space. That's my future. That's how I see space exploration going. As far as technology, there's a law called Moore's law in computer technology, where technology just keeps growing, very quickly. And if you just look back in the last 100 years, we went from the Wright brothers to space shuttle in leaps and bounds. Our technology for space, our technology here on Earth, and our technology to help us in space is just growing at a rapid pace. I see a lot of the things we dreamed about as kids or science fiction writers wrote about becoming reality quicker, sooner than you realize. You had mentioned earlier about tricorders and communicators. Well, we have tricorders. We have something similar to tricorders now. Our communicators are our cell phones. Who knew back then, back in the '60s, that we would have a cell phone that could reach around the world, or technology through satellites that allow us to have a podcast here in several different countries worldwide. I see technology, because of space and space exploration, just growing in leaps and bounds, not only for science, but for medicine, and for the benefit of mankind or humankind. It's like I said earlier, it's a wonderful time to be alive. Instead of new technologies, instead of revelations happening every few months or every few years, we get them every few weeks now. I think that the future is going to be very interesting.
And if you look at all the benefit that space exploration brings to people in general as well, right? So there's so much technology that has helped people all over the place, and if you look at technology in general as well, you can see, looking back at the tricorder, you have the ultrasound, right? You can look inside your body and see what's going on. You have MRIs, you have all sorts of other equipment that helping people improve their health, which is really exciting to see. And it's like you said, things keep evolving at incredible speed as well. So we have been talking for a little bit more than 1 hour here, and getting close to the end of our conversation. One question I usually ask our guests is, do you have any recommendations about books, music, or movies to our listeners? Not necessarily technology related, but anything that you may find that interesting, that our audience may be interested in reading and listening, or watching.
Oh, that is a good question. Do I have any recommendations about books or movies? What I, and this is just me, what I find interesting are some of the movies that discuss the what ifs of, how do I put this? Back with Star Trek, back in the 1960s, they discussed things like warp drive and more complex mathematics that and theories that Einstein and other scientists had about traveling faster than the speed of light. I find that there are some movies like Interstellar that discuss new concepts about time travel and about black holes and such technology, and such space anomalies. I find that very interesting. Nowadays, what I do is I take in the data that I see out there about the new things we're finding in space, the black holes. The it's I don't have anything specific, to be honest. There are a lot of shows out there that do discuss, and there are a lot of books that talk about things in the past and certain science fiction concepts. But I don't have anything specific. I will tell you this: nowadays, and when I was younger, I read as many science. I read science fiction a lot, and I looked at science fiction shows a lot, and that helped me keep my inquisitiveness. That helped me keep the hope of when I would see these shows and when I would read these books. I don't have anything specific, but I like the old. I like the old stuff. I like I like reading about Einstein's theory. I used to read about black holes. I used to look at movies about time dilation. I used to read articles or short stories, be it science fiction, about what could happen once we do get past the moon and our solar system and into deep space. Those stories, those books kept me thinking about what if, kind of like when I was younger with Star Trek. When Scotty would come up with a new piece of technology to help save the ship, or you had warp drive, or you had phasers, or you had communicators. It's like, this is so cool. Can this happen again? Will this happen in the future? And it has. And nowadays, with the access to information and books and learning on the internet, a lot of the data out there keeps you thinking about what's going on. And I hope I'm explaining this well. It's really hard for me to get these words out. But
You're explaining well. You're explaining well.
okay, but I'm trying to say that I don't have any specific book. I don't have any specific movie or show. I find a subject that I like. I find a subject that interests me, something that gives me an idea of what could happen. To the extent was when, and I'll give you an example. When I was younger, and I was watching Star Trek or Space 1999, which was even closer to the moon because it was based on the moon. Could we develop something like that? Could that happen? Well, now as an adult, I'm seeing we're doing something similar to that. It's not exactly the same, but we are doing something similar to what they had, be it the communicators or be it theories on warp drive or the tricorders or laser scalpels that they had in those science fiction shows. Those are, present now in many operating rooms. Space 1999 with the moon base. We're planning on getting a moon base up there eventually. I look at the stories now and I see what they think humankind can do in the near future, be it land on an asteroid, be it colonize Mars, or deep space exploration, finding the origins of our universe. Because of technology advancing so much quicker than it did back then, these stories, and because of the data that's available to us and the science that's available to us now, these stories that I see now, they're so informative. They're so predictive of the future that I have hope that a lot of these stories that I find interesting, these books or anything on the web, that in my lifetime I'll be able to see the next great technological leap. For a generation before mine, it was going to the moon. In my generation, it was a permanent space station. I find myself very lucky to see the first time humans have a permanent presence in space. Ever since the first launch of Flight 2A to the space station, where we put 3 astronauts up there, there's always been a human in space since then, and I don't think it's going to stop. And if you look at a lot of these stories and read how they their concept or their thought, their hope for the future, there are many different stories out there, but they all have an underlying basis, an underlying story of where we're going to be going, and many of them just give me this idea like, wow. And we even discussed this at NASA with the other, my other coworkers. When we have some downtime, we'll be discussing about new stories, and whether it's a new telescope or whether it's a new concept for a space mission, exploring comets, going to Pluto, and taking the best, most high res pictures we've ever had there. Exploring the new moons of Jupiter and Saturn. Um, that's I don't have a specific book, like I said, or a specific story, but all these stories just all congeal, all fit together to give me that hope, to give me that thought of what could happen, and that keeps like it did when I was younger. That keeps my inquisitiveness alive, my thought process alive, my idea of what's going to happen in the future and how can I be a part of it. And if you take that with a healthy curiosity about what we have now with computers and with the technology we have and how that fits into the current space technology we have, the current systems that we're using right now, and how they can advance in the future in such a short amount of time, in just 20 years. Imagine where we're going to be in 20 years. That's what these stories, that's what I look for in a book or in a story, how we can take what we have now and go into the future. And it just keeps that thought process alive. As I had mentioned, we still do that at work. At before COVID, when we would all sit together, we would discuss these things, and how interesting it could be, how that would affect our lives in the future, and how the younger generation can be a part of that. Again, like I said, it's a wonderful time to be alive, and you have so many opportunities out there to take what you learned and what you think can happen and form your career. Uh, there are so many more avenues open for you that weren't present when I was younger. I feel very fortunate to get to work at NASA, and it's a lifelong dream, and I feel very fortunate that that dream did come true. I mean, I get to work on the space station simulator. I get to work with some of the brightest people in the industry. I get to solve problems that are unique. I get to help solve issues that have never been seen before, and have a direct impact on the space exploration, the human space exploration. If you just keep thinking, keep keep your thought process, keep your fantasies, keep thinking about the future and what these stories, these people write about concepts that could come true very quickly. Younger generation of today have so many opportunities, so many avenues to think about. You just have this flood of data out there. This that you have to keep that thought process alive. So I hope that answered your question. It wasn't exactly one book or one movie or one story. When I was younger, there weren't very many options for me. Hence Star Trek and Space 1999 and Carl Sagan's Cosmos show and a few public broadcasting system shows that we had on space. We didn't have a lot of data back then, but there are so many things out there now, so many stories, so many avenues of technology to explore. Keep reading. Keep fantasizing about what could happen, because it will. Many of these will come to fruition quicker than you realize, and don't think that you can't be part of it. If you find something that's interesting out there, explore, ask questions. There are many different ways to find the answers, and you may find something that you like. And again, technology and our education, our knowledge is increasing faster than ever, and you can be a part of what you dream about. You can be a part of what you see out there. It's not as difficult as you think. Keep that healthy. Keep those healthy questions going, and keep researching what you like, and you can be a part of it. It's a great time to be alive, and it's a great time to be in to study science and space right now.
Yeah, it was a very good answer to my question. And I think the key thing you said here is keep dreaming, keep thinking about ways of making those dreams become a reality. And also, you're an example that dreams do become true. So I think it's a very good answer for my question here. So thank you so much. And as we're getting close to the end here, anything you wanna share in terms of contact information, websites, or anything you wanna mention here for people that may wanna send a question, or I can put on the meeting notes for the
Yeah,
episode.
I can get you some contact information later if you wish. Um, yeah,
Yep, we can do that.
but
Yep.
yeah, I can do that. There are several websites out there that you can go to and learn about anything space related, anything computer related, and what NASA's doing. Yeah, I'll be able to. I'll get you some stuff, Marcelo, and you can post it.
Thank you. And Albert, it's been almost 1 hour and a half. It's been a privilege talking to you. So it's absolutely fantastic listening to your experience and the work you have been doing. And again, I want to thank you for taking time away from your son and your life here and sharing the experiences. Also being my first English episode. It's like I mentioned before, it's the episodes are in Portuguese, but we wanna share your experience with the audience in Brazil and motivate them to learn English and motivate them to learn about the space program and NASA and the work you're doing. So it's yeah, and you shared a lot of information and very inspirational in terms of motivating people to get into the technology path here. So thank you so much for your time, and I hope you have a good rest of the day and greatly appreciate it.
It was my honor to help, and if I helped just a few people, I would consider it a great honor and a great pleasure. So, obrigado, bom dia, and you guys have a wonderful rest of the day.
Obrigado. Forte abraço. Chegamos ao final de mais um episódio. Agradeço a todos a atenção e o nosso site é OsProgramadores.com. Participem e até o próximo episódio. Um bom dia para todos.